Hey everyone, today we're going to dive really deep into LLMs and I'm going to show you a language model. It's not a large language model, just a regular language model that I built back in 2019. And the reason why I'm showing Bitcoin here is because I could have been rich twice now. First in 2015 when my friend told me to buy Bitcoin, and now look at that price. I mean, both of us didn't buy it, so I guess both of us are not rich. So that kind of sucks. We both fumbled. But then also in 2019 when I built a language model, and all of a sudden a few years later, ChatGPT came out and with a language model of its own and went crazy. So you can see I have this language model that I built on top of a language philosopher's writing. And yeah, I fumbled the bag twice, but I won't fumble it on the next one because I'm going to use GPT to help me figure out what the next trend is and I'm going to capitalize on it. So so when did I write this GPT model? I wrote this GPT model 5 years ago, or sorry, this language model in March 6th, 2019. That was a bit more than five. That was like 5.5 years ago. But yeah, like what even is this language model doing? Let's just like dive into, let me grab a screenshot. So in this video, since we're diving into ChatGPT and how it works, or specifically how a LLM is built under the hood, I'm gonna dive really deep. But you don't really need to understand anything about machine learning or anything about AI. I'm gonna talk in the most simple terms as possible and try to introduce the basics. So pretty much how these large language models, how ChatGPT is trained, is from this process called reinforcement learning with human feedback. And it generally involves three steps here. Step one is pre-training, and that's what this model is essentially doing here, is it's creating a language model that's pre-trained on a large data set using traditional supervised learning. Using this step helps the model learn general patterns and language structures and a broad range of information. So it basically learns how to model a specific language. Afterwards, we collect human feedback, and then humans provide feedback on a set of outputs generated by the pre-trained model. So we're kind of fine-tuning the model. Like the first step is creating this language model. Then we want to fine-tune the language model so it produces outputs that are more useful for humans. And those are kind of the two steps. Like you create this base model and you train it to learn the structures and general patterns of a language. And then after you use human feedback and reinforcement learning to make those outputs more useful. That's essentially how ChatGPT is trained. And this language model that I built here pretty much just captures the first part, which is pre-training. I didn't use human feedback I didn't use RLHF in order to make the outputs like more useful. That's why you'll see the outputs of it is kind of like garbage. I mean, it's not garbage. It is kind of cool, but it still won't answer questions and help people out the way that ChatGPT does. So let's get into it. So this is the language model that I built 5 years ago, and what it's doing is it's learning how to speak like this German philosopher, right? So it'll specifically it'll model the language. Basically, that's why it's called a language model. So here's the code, and you're gonna see the internals of a language model. I pretty much, back in the days, 5 years ago, Keras was a very popular language for building machine learning models. It was just like an abstraction on top of TensorFlow to easily build like neural networks with tons of layers instead of like building the layers one by one and then doing like the math in between there. It abstracts a lot of that away. So the first step here was actually just importing some of the libraries. So I imported Keras, NumPy. I also imported my Google Drive. And the reason I imported a Google Drive is because for all, or sorry, let me go here. Actually, yeah, let me quickly explain at a high level what I'm doing here. So the first, like I mentioned, we're diving deep. Like what I did here is the first step here, which was actually creating a language model. And the first step of training an AI language model is essentially the supervised portion. This stage is often called language model pre-training, and it's a crucial foundation for models' understanding of language patterns, grammar, context, and general knowledge. So we're teaching this model patterns in languages, grammar, context, and just general knowledge, and like we're just encoding it with that information. So here's how it works. Objective. The model is trained with a simple objective. Given a sequence of words, it predicts the next word. For instance, if the input is cat sat on the model tries to predict mat. This process is known as next token prediction. Dataset. The model is trained on a large and diverse dataset, such as books, articles, websites, and other text sources. This helps it learn a broad range of information, including grammar, idioms, cultural references, facts, and general knowledge. Step 3. Learning patterns and structure. During supervised learning, the model learns statistical patterns in the data, such as common word sequences, syntactic structures, and associations between concepts. It doesn't understand language like human, but it learns probabilistic associations that make it very good at generating coherent text. So the key word here is it learns probabilistic associations. Limitations. At this stage, the model is not yet aligned with specific human values or task preferences. It may produce plausible sounding but unhelpful bias or irrelevant responses because it hasn't yet received targeted feedback on what makes a good or bad output. That's kind of where the reinforcement learning with human feedback is used. So cool. So I think what's important to remember here is like the objective of like how we train this model is we train the model to become a next token predictor. So yeah, that's essentially what I'm doing here. I'm loading in the corpus of dataset, the dataset. That's what step here is. Step 2 here is. So I pretty much load in this dataset, which is a bunch of text by this German philosopher, because my goal was to teach a model to talk like this person. So you pretty much just train it on all this language, and it begins to talk like this German philosopher. So yeah, so this is the data set. It's pretty much just like a super big piece of text of like a lot of his different writings, and this is what I'm going to train the language model on. And sorry, go up. So I pretty much load it in, and then once I load it in, I start vectorizing the sequences, because computers, everyone knows that computers kind of work in zeros and ones. So it doesn't really understand words. So you need to vectorize your inputs. You need to take words, which is usually ASCII characters, and then convert those letters or characters into numbers. And then that's usually what's fed into the model. So that's what this place is doing. I'm actually creating the data set. I'm creating a data set like this, where I'm like pretty much scanning through the input and grabbing a few words, and then collecting that as input, and then grabbing the next word and storing that as the expected. So I start to build a data set like this, and in code it will look like this, where you have a sequence of words and you have a target. And this is like the supervised data. This is the labeled data set that the supervised model or like the supervised training will run on. Because with supervised learning, you need a data set. And the good thing about this is you can generate the data set without human labelers. You kind of just like read over the text, like grab a few words, and then that's the input, and then grab the next word, that's the expected output. Then you grab another few words, and then that's the input, and then you label it with the next word after those few words, and it builds a data set like this. Hopefully that's simple enough. That's essentially what I'm doing, and as I mentioned, we need to vectorize this so these eventually become like zeros and ones that are able to be fed into a model, because models don't understand characters. They only understand numbers. That's what I mean by vectorizing. So once I have this data set, like I mentioned, the next part is actually training a language model. And you could train a language model using a lot of different architectures. ChatGPT is built on the transformer architecture, but here I'm using the long short-term memory architecture, which is like a kind of a precursor to the transformer architecture. And there's tons of different architectures like recurrent neural networks, just regular neural networks, long short-term memory, and each of them like have different mechanisms for like it's basically a different configuration of the different neurons. And some of the I would say like some of the innovations between the different model architectures were how it could like relate information between each other from like further distances. So like long short-term memory, the innovation that was made when they created this was they built a model that's able to retain some memory. So if it's looking at like a piece of text, it could remember like further up the text or further up the text, like things it's seen before. So it had like some sort of memory, versus recurrent neural networks really have no memory. So I'm only saying this to just say that like there might be new architectures in the future, but a language model is simply a language model, a next token predictor. And right now, transformers are pretty much the model that people are using and like are the best right now at modeling languages. They're state of the art. So cool. So I have the step. I load in the data. I load in this data. I turn this data into a data set. I build a simple neural network, and I begin training the neural network on my data set. So how does that training work? Essentially how it works is you'll feed in. So think of basically, I think I have a good example here of how this all works. Forward pass. So basically, when you have a neural network, you want to essentially train the weights. That's or you want to like you want to set the weights of the model. Usually they're randomly initialized between like 0 to 1, and you want to basically fit the data set. So how you do that, how you update the weights so that the weights fit the data set, is by supervised learning. So how it essentially does that is, first you do a forward pass. The model takes an input sequence and then generates a probability distribution over possible next words. So pretend it takes this input, and it will generate a probability distribution of what it thinks the next word would be. So it could be like then. Probability distribution, let's say then with a 90% chance. Hello with like a 5% chance. And then like what again with like a, so it basically like it's building a probability distribution and of all the words that it could possibly be. And then it makes a guess based on that. So essentially when it's training, that's kind of bad explanation. Let me just like go through like how it's actually training. First, it takes the input and it like shoots out a guess. Let's say it says what? That's clearly wrong. The expected was then, right? So we usually, what happens is when it gets wrong, we calculate the loss, like we calculate that it was wrong, and when we run it through all the input, and we usually do that in batches, we add up the amount of times that it got wrong, and that's the loss value. Then we use that loss value to update the weights of the model so that it minimizes the loss value. So if you run this input again through the model, the loss should be lower than the last time. So you kind of do this like circle of like for feeding the inputs through the model, getting like the predictions and comparing it against the expected, calculating the lot like how many it got wrong, and then calculating that number, and then updating the weights of the model so that it could like reduce that number on the next run. And it does that using back propagation, and that loop keeps going over until the loss function is like lowered, and that we so basically the goal is that it doesn't get any of these wrong, and that's kind of what we mean by fitting the model. And you could like overfit the model so that like it's never wrong, but like overfitting is a different story for a different day. Like you can get 100% accurate on a data set, but it might not generalize well to other data sets essentially. Whew, that was a mouthful. So I talked about a bit about the training, how we train the model. After that, once we train the model, now we have this model that understands languages. It's essentially a next token predictor. What we do next is, what do I do here? Function to loop. So now I kind of like, this is how you actually start predicting or generating text using this next token predictor. So you start with a few words, right? So I start with this separate moral exposition in the vouchers of Christianity, right? And then given the next token, like given that it's a next token predictor, it tries to guess the next word. So you could see it output this word and it guessed this next word. Then it will take, then you like loop the model through, you like loop the text through this output. You literally take this text that it output, and then you feed it, and then you try to get it to predict the next word. Then you take like this text, and then you get it to predict the next word after that. And then you take this text, and then you get it to predict the next word. So you could see like we trained the model to be able to predict the next word, and we trained it based on the data of this German philosopher. So it should be like outputting, it should be like guessing the next word like based on the probabilities that that German philosopher would have used those words given like the previous words, if that makes sense. And yeah, that's like a pretty deep dive into, that's literally all my code. And you can see, let's see, that's literally a language model. And yeah, you could see like the temperature here gives what the temperature does is it essentially resamples the distribution. So the lower the temperature, I think the lower the temperature, the more creative it will be, and the higher the temperature, the more like, let me see. I noticed ChatGPT had this thing as well. Temperature, what's temperature? Lower results in less, as the temperature approaches, the model will become more deterministic. Okay, I see. So what this temperature does is it like adds some randomness when we're like picking from the distribution of words. So it's actually when it takes like an input, it produces a distribution of words. Like it might think, like what I mentioned, it might be of, the, strength, like all these different words, and it's gonna try to choose, and it's gonna randomly pick from those based on the distribution. I don't even know if that makes sense. It makes sense in my head because like pretend we have the, I keep going back to this. pretend we have the sentence or the two words I love and we want to predict the next word. What I mean by probability distribution is the distribution, like we basically take all the possible words that could come after I love and assign like a probability that that word will be used next. So you might be at 90%, him might be at 5%, her might be at 3%. And then we choose, like basically we choose from, based on, we randomly pick from those options based on the probability. So 90% of the time it will just use you. 5% of the time it will use him. 3% of the time it choose her. So that's why these LLMs hallucinate, is because they're just like picking randomly based on this like probability distribution. So at sometimes they might choose something that's like 1% chance or like 1% of the time used. So yeah, like 1% of the time it might say I love no one, and but that's still part of the distribution. And like out of 100 GPT runs, it might use that one, and that's why LLMs kind of hallucinate. Yeah, you could see that I'm using different temperatures, and the lower the temperature, the more that, like, if I put the temperature basically to zero, it will just start it will just like copy this exact text and spit it out. But we want a little bit more creativity, so we like up the temperature. Yeah, that's a pretty deep dive into this language model that I built in 2019, 5.5 years ago before GPT. And I hope y'all learned a little bit how language models work. This is pretty much the first step in a language, building a language model. The second step is reinforcement learning with human feedback, which I'm going to be doing a video on, dropping that video on Sunday, or like right after this. And yeah, that's pretty much it. Like, this probably wouldn't have got me rich because it's a very simple model. GPT's model is way bigger than 128 neurons. It uses a way more complicated architecture. It's trained on a much bigger data set than the one I'm using. And yeah, they also use reinforcement learning with human feedback, which I didn't do. So I probably missed out on a bag here, but I'll catch you on the next video when I talk more about reinforcement learning with human feedback. Thanks for watching.